Hi students, hi parents, hi everyone. I'm Teacher Meng Yee here. Hello. Great to have all of you joining us today here. Yeah, I'm sure you all know what we are all in for today, right? You all know what we are doing today? Hi, hello. Hi. Yes. Okay, so for today's session, okay, we'll be going through this topic on electricity. Now, can I just see a show of hands, the virtual hand? How many of you feel that electricity is a difficult topic? Okay, quite a number of you. Yes. And that's also, okay, some of you find it manageable. It's an okay topic. Now, no matter it's easy, manageable, or difficult topic, now, why did we focus on this topic? Why are we focusing on this topic? It's because this topic, if you look at the PSLE papers, it has been heavily tested in the last 3 years. Okay, for in PSLE. If you are a P6 student, you should have seen the PSI papers, right? Okay, so we realize that this is a heavily tested topic, and that's why we want to make sure that all of you master this topic. Okay. I see that there's a few of you who have not learned electricity. Then I believe you are P5 students, right? How many of you have not learned electricity? Can you raise your hands? Okay, I think only a few. So for those who have not learned electricity, never mind. Okay, just take this as a topic starter. Okay, you just learn it from fresh. Okay, you're going to learn this pretty soon. Okay, this is a P5 topic. So sometimes you learn it as the last topic in P5, sometimes earlier. Okay, but for P6 students, you must already be prepared for the PSLE. Okay, all right. So I hope all of you have the document, right? So if you have joined our MyStretcher Telegram channel, okay, you should have seen the document. If not, you can join the Telegram channel or ask your parents if they have the document with them. Okay, and I hope those who have it, you have already tried. Okay. Now, if you do not have the document, you can click on the link in the chats. Okay, you can access it there. Okay. Oh, P3. Wow. Okay, P3. Okay, this webinar, this sharing session is actually more for P5 and P6, but of course, if you are P3, P4, okay, feel free to listen and learn something new. Okay? K1 not lying, right? Helen, are you lying? You're yeah, K1. Okay. Well, you are learning electricity very early. Okay, very young. Okay, now without further ado, because we have a lot of things to share about this topic, I prepared quite a few questions to go through. So I'm going to start going through some of this. Okay? Okay, Helen. Right. Yes. P6 becomes K1, Okay. Okay, so like I said, right, even if you find it easy, even if you find it manageable or difficult, doesn't really matter. What matters is whether you can get full marks. Okay, you might find it easy, but if you make an error, if you make an error, you are still not going to get full marks for it. Okay, so we're going to go through all the important tips for this topic. Right, so I have created these summary notes. I've went through great effort to summarize it properly. So only touch on the key important points. Okay, that is really necessary, to score well for the topic. Okay, so the first part is the very basic part on electric circuit. Okay, so you need all the wires, switches, bulbs, batteries, or other power sources. Okay, so you must know what their functions are. Right, so in a circuit, in order for it to light up, no, sorry, let me see what you all have in the chat. Can you note it down? Yeah, of course you can note all this down, no problem. Okay, if you are P3, P4, you have not learned this topic, or even if you are P5, you have not learned this topic, no worries. Okay, just learn along the way. But I'll be a bit faster because our target is more on the P5 and P6. who are going for the exam soon. Okay, so you just try to catch whatever you can catch. Okay, right. So in a in an electric circuit, these are the components we have. Right, a switch. You open and close the switch. All right. Then you have the battery. The battery, I believe, no matter how old you are, you should know what a battery is. Right, you use the battery to operate some of your appliances in the house. Okay, like maybe for example, remote control, I don't know, electric fan. Right, nowadays very hot, right? And you go around you using an electric fan, your portable fan. So all those contain a battery. Okay, and there are wires inside your portable fan. And just imagine the light bulb is the fan. Okay, so this light bulb will light up, the fan will start spinning. All right, so you will close the switch in order to let your fan turn on, to turn on your fan. All right, so that is a closed circuit. So that allows electricity to flow through, or you can say allows electric current to flow through. And when you switch off, there is an open circuit, so there's no electric current. All right, now for a light bulb, very importantly, you must know how to connect the light bulb in the circuit. Okay, so light bulb has two important parts, metal tip, metal casing. Okay, so this is the tip, this is the casing. Right, so you see how the light bulbs are, how the wires are connected to the light bulb. One wire to the metal tip, one wire to the casing. Okay, so that connection must be, it must be there. You cannot connect it incorrectly. Okay. Yeah, so let me move on. So if you look at this, now in this case, sometimes you may not need a wire if the light bulb is directly connected to the battery. So we put the metal casing in contact with the battery. Okay. So that is connected already. Then you just need a wire to connect to the metal tip. So as long as the metal tip and metal casing are connected in some way, be it through wire or through direct contact with the battery, then it's a closed circuit and the light bulb can light up. Okay. Now, if you look at how the battery is drawn, a battery, you draw it like this. Okay. It's not really necessary to draw a plus and minus. So you draw it one big rectangle and the head of the battery. Now, this may be something simple, but I have come across P6 students who just draw a rectangle for the battery. They have forgotten how to draw a proper battery, which isn't difficult, right? You just need to draw the body of the battery and the head of the battery. That's it. But somehow there are P6 students who just draw a rectangle. Forgot how to draw a battery. I don't know why. Okay, so make sure you know how to draw it properly. All right, so later when you go through the questions, please draw them properly. Now, we can represent open and close switch with just this piece of wire. So open means you leave a gap. Close means it's just a line. Okay, we have these two dots to tell that it's a switch. Otherwise, it may just look like a straight line. Okay. Now wires. Now one thing about wires is that when you draw your electric circuit in exam, now these wires usually will tell you use a ruler, draw nicely. But in actual fact, is ruler really necessary for the PSLE? I would say not really. But you still have to try to draw neatly. Okay, do not draw like all over the place. You may not really need to draw a perfect straight line using a ruler. You can freehand and try to draw a straight line with your free hand, but it has to be neat. Okay? And all the circuit symbols here, you do not have to draw them perfectly to scale. Okay, you can draw them slightly larger, slightly smaller, doesn't really matter, as long as they are clear. All right? And a few things is, one more thing is that when you draw your wires, now you do not draw your wires overlapping. Okay, so do not draw wires like this. Like this. It's overlapping. Okay? Meaning that you try to put the wires across each other, but in actual fact, when you draw it like this, it's considered they're all connected. Okay? Instead of being separated. All right? Okay, one of you asked for the battery symbol is the short line, the positive terminal. Okay, so you look at the direction, right? The short line is the negative terminal. The long line is the positive terminal. Okay? But this doesn't really matter that much for PSLE, but okay, just for your knowledge, the more accurate way of learning it, the long line is the positive terminal. So it's in the correct direction now. Okay? Do we have to label the drawings like when we draw a bulb, when we label it on write it as bulb? If they ask you to label, then you need to label. Okay, let's say it's usually the circuit symbols will really tell you what it is. Okay, so you don't really need to write that it is bulb. But if let's say they ask you to draw bulb Q, and then you have to label it is Q. Okay, you understand what I'm saying? So if there's a letter tag to that component, maybe it's a switch X, and then you have to write it is switch X. Okay. Otherwise, it's understood when you draw the circuit symbols, it's understood what it is. All right. So I'm just answering some of these Q&A. Yeah. Must I draw wires with a straight line? Just like I already mentioned. Okay, it's okay if you don't draw perfectly straight line. You don't really have to use a ruler, but you try to draw as neatly as possible. You may draw slightly curved, it's okay. All right. Because what is really essential to get full marks, to get correct, is your connections. Okay, your teacher said they can overlap the wires if you have like a bump when they meet because okay, but that is not what you have what you learn in PSLE. Okay, so try not to overlap your wires because you don't learn that. Okay. Hmm. Okay, let me continue. Next part here. Now, conductors and insulators of electricity. So there are certain materials that can conduct electricity, and you should know all metals can conduct electricity. Okay, they're all conductors. So they allow electric current to flow through. But is it only limited to metals? No, right? Okay, there are some materials such as graphite. Graphite is actually used to make your pencil lead. Okay, so if you use your pencil lead and connect it to an electric circuit, a circuit tester, the light bulb is going to light up. Okay, so it's an electrical conductor, but this is not a metal. Okay, so all metals can conduct, but there are some non-metals that also can conduct. Okay, now coming to the most important points. One of you asked, is this needed for PSLE and P5? Yes, all these are needed for PSLE. Okay. One of you asked, does arrangement of batteries affect bulb brightness? Yes, they do. But in PSLE, arrangement of batteries are not in syllabus anymore. Okay, so you do not need to be too concerned about the arrangement of batteries. Just make sure your batteries are connected correctly. Okay, the opposite terminals must face each other. Right, like how it is drawn here, right? Opposite terminals must face each other, plus to minus, plus to minus. Okay? Okay, one of you asked, will graphite be tested? I would say it may be tested. This one we will not be too sure, but definitely you must know all methods will be tested. Okay? And just learning one more graphite, which we know as is pencil lead. Okay, I think it's not difficult to remember. So maybe it will be tested, but not so likely. Okay, but just good to know. Okay? Okay, move on. So this part very important. Factors affecting brightness of bulb. Now, in almost every PSLE paper, there will be at least one question on the brightness of bulbs. Okay? Maybe there will be one other question on the circuit connection, which bulb will light up, which bulb will not when the switch is closed. But those kind very easy. Okay? So this one is the slightly more difficult one. The factors that affect brightness of bulb. So we have number of batteries. So in your syllabus, we only learn the batteries arranged in series, meaning that they are all in the same path. Okay, you put one battery after another in that same path. So that is in series. All right. So when the batteries are connected in series and you add more and more batteries, this light bulb are going to light up more and more bright. Okay, so as you can compare, right, we have bulb C being the brightest, bulb A being the dimmest. Now, this line shows the brightness, but in actual fact, we don't draw these lines when we draw the circuit. But this is just to illustrate to you their brightness. Okay? But one thing is when we add too many batteries, now you see we have 3 batteries, maybe when you add up to 5 or 6 batteries, now there will be too much electric current, and that may result in the bulb blowing. Blowing means that you know the bulb inside got filament, right? There's a piece of wire called the filament. Okay, so this piece of wire might melt. So when it melts, it causes a gap. Okay, it causes a gap to occur, and it becomes an open circuit. So this light bulb cannot work anymore. So that's why we call it blow, or another word is fuse. Okay, to fuse. Okay, so yeah. Okay. No. There's only parallel in series. All right. A bit. Yeah. There's only parallel in series. Okay. One of you said that your teacher said it's okay to draw overlapping as long as you have the. No. Actually, overlapping is really not the correct way to do it unless you know how to draw it properly. Right? So try not to draw overlapping wires. That's my advice. Okay? Because overlapping wires means that these wires are connected. They are connected to each other. Okay, what I mean by overlapping, right, is for example, this. So there might be some junction, right? So this is like a T junction, right? So these wires, you can say they are this is not really overlapping. So overlapping is like a T shape. It's like a plus sign. Let's see if I have one. I don't think I have one. Because we don't have overlapping wires. Okay, so overlapping wires is when we have when you're supposed to have this circuit here. Okay, let's say for example, I can illustrate properly. Okay, so overlapping would be that let's see how I can talk about this. Okay, no. Okay, so what we mean by overlapping is when your wires are drawn like this, right? Okay, so when this happens, it means that all these wires are connected to one another. While in actual fact, when our real intention is not really for them to overlap, not really for them to be in contact with one another, okay, then you have to draw it a bump. But we don't learn that in PSLE. Okay, so basically the advice is don't draw overlapping wires. Okay. Okay, coming back to this part. All right. So we have. So just now we talked about the battery, right? So battery is only one arrangement, series. So we don't learn about parallel arrangement of the batteries. Then we talk about the arrangement and number of bulbs. Okay, first we talk about the bulbs in series. So again, the bulbs are arranged in one single pathway. Okay, so we are adding more and more bulbs in this series arrangement. So what happens is when you add more bulbs in this series arrangement, they become less and less bright. So those in circuit C will be the dimmest. Those in circuit A, or rather bulb A, will be the brightest. Okay, so you can just take it as, okay, I have 2 batteries. So these 2 batteries are like candies, sweets. Okay, and this box of sweets only shared by 1%, as compared to this same box of sweets shared by 3%. So each of them have a smaller share. Okay, so they basically have less electric current flowing through them. All right, less current flowing through them, so they become dimmer. Okay. Yeah, please don't draw overlap wire, okay? Because some of you say your teacher say can, some of you say teacher say cannot. Yeah, basically the idea is don't draw it. All right. Okay, now so we can have the bulbs in series arrangement, we can also have the bulbs in parallel arrangement. Now, in this case, so when we increase the number of bulbs that are arranged in parallel, somehow these bulbs will receive the same amount of current flowing through. Okay, so initially with two batteries, this bulb has a unit of 4 brightness. Okay, brightness of 4 units. But when I connect another bulb in parallel, these two bulbs have the same brightness. So nothing has changed. They are all equally bright. As bright as before also. Okay, so do take note the difference between series arrangement and parallel arrangement of the bulbs. Alright, now some students face issues drawing bulbs in parallel. Now you see that, okay, maybe they are parallel to each other, very easy to see, but sometimes the bulbs are not so easy to see. Like for example, right? Okay, let's say I have my bulb here. They purposely put the bulb sideways. Okay, then I have a battery, for example. So how do I draw a bulb that is parallel to this bulb? So the idea is that now you form a loop with this light bulb first. So this light bulb can light up. Then I want a bulb that is parallel to this light bulb. So you must draw wires around this existing bulb. What do you mean by around? So you must have a wire that is on this side and a wire that's on this side. Okay? Then you can just connect them like this. Okay, now so this light bulb is parallel to the existing light bulb. Okay? Sorry, I draw wrongly. Need to connect to the metal tip. Metal tip. Okay, can. Okay, so you have to connect it across around the existing light bulb. Okay, I closed the gap already. And I close this gap also. Some of you are very tricky. Okay, no gaps. Yeah, let me read some of your questions. Okay, so batteries, we don't learn in parallel. Okay, let me just go. Will what is inside the bulb be tested? Yes, what inside the bulb can be tested. But that is very basic, Dylan. Basically, inside the bulb, we have the filament. That's the main thing. Okay? You don't learn short circuit, okay? So don't talk about short circuit. Yeah, circuit is not in the syllabus. Lines not straight is okay. Why is it when you do experiment in school, some light bulb did not light up? I cannot really tell unless I can see the setup. So there could, unless it's really like the light bulb fused, or there is not enough electrical power. Okay, not enough electrical energy. So you might have to use more batteries, Elsa. Okay. Okay, don't put so many comments in the Q&A, because there's only Teacher Fu and me. So we're trying to look at all your important questions. Okay, we're trying to answer all important questions. Okay, I am flashing. Okay, where can we find these worksheets that we are going through? Shay, can you share the link again? Yeah. My camera, my camera has an issue, is it? Okay. Let me just do my camera again. Camera is very sensitive. Okay, not flashing anymore. All right. So let's continue. Okay, one of you asked what is tungsten versus filament. Now, basically, the part inside the bulb is called filament. Okay, you see here, right? So this is the light bulb. This part is called filament. And filament is made of tungsten. Tungsten is a piece of metal. Okay, it's like iron, aluminium. Those are different types of metals. So tungsten is another type of metal used to make the filament of the light bulb. Okay, I hope that is clear. Okay, moving on. Right, so regarding this brightness of bulb, no, so what we have for you here is this formula that you can make use of. This formula is basically just do a fraction. Okay, you use a number of batteries as the numerator over the number of bulbs in the path as the denominator. So for example, right, let's use these two exact example in number 11, these two diagrams. So number of batteries, so we have two batteries. Okay, number of bulbs in the path. So in the path means that in this one's path, how many batteries are there? So there is two. So which means that this is equals to 1 unit. The brightness of the bulb is 1 unit, for example. Then we compare that to a parallel circuit. So number of batteries is still 2. Now, for a parallel circuit, we have two paths. This is one path. This is a second path. So for each path, we can calculate the brightness. Okay, so in each path, for this case, they are all 1. There's only one bulb in each path. So this is 2 units. So therefore, the bulbs, when they're arranged in parallel, they will be brighter than those that are in series. Okay, so you can make use of this formula, okay, to calculate the brightness. Now, this is not an actual formula that you will learn when you're in higher level. This is not an actual formula. This is just a tip, just a strategy to really help you determine their brightness. Okay. Does it glow when heated? If you're talking about the tungsten, yes. So when electric current flows through, okay, the tungsten gets hot, so it starts to glow. Okay, if that's what you're asking. Okay, so this is another example. Now we have 4 batteries. Okay, so on the left side, we have 4 batteries. Sorry, we have 4 bulbs, not batteries, 4 bulbs in parallel. So in each path, there's only one bulb. So the brightness is 2 over 1. 2 batteries over 1 light bulb in the path. So it's 2 units. Now you compare that to the one on the right. Now this one on the right is a bit more complicated, sophisticated, right? Because we have actually 2 batteries in the same path, and these 2 batteries are parallel to another 2 batteries. Why I keep talking about batteries? Sorry, bulbs. I have 2 bulbs in series, but these 2 bulbs are parallel to another 2 bulbs. Okay, so this is one path. This is another path. So for each path, okay, we still have the 2 batteries. So the 2 batteries will power up the 2 bulbs in each path. So essentially only 1 unit. Okay, so if you compare that to the one on the left, then the one on the right, these bulbs are dimmer. Okay, but essentially for all these bulbs, this one, all these 4 bulbs, each of them are equally bright in this case. What happens if I have another one, I add another one that only has 1 bulb in this path? What happens to this? If I only have 1 bulb that is, sorry, I keep drawing wrongly, doing too fast. Okay, so I need to connect it to the metal casing, metal tip. Okay, so you see, I have only 1 bulb in this path. I still got the 2 batteries, so 2 over 1 is 2 units. So which means that this single light bulb will be brighter than those in the other path. Okay? And okay, we're going to move on to the last part here on the notes before we go to the questions. All right, so advantages and disadvantages of using bulbs in series and parallel. All right, so if you look at bulbs in parallel first. So the advantage of using bulbs in parallel is that the bulbs are brighter than those in series, as you have seen here, right? If I compare those in parallel compared to those in series, those in parallel are brighter. So that is an advantage. Okay. And when one of the bulb fuses, the remaining bulb can still light up. Okay, so if this bulb fuses or blows, this bulb can still light up. Okay? So that's an advantage. But the thing is that because I have two bulbs that are so bright, much brighter than those in the series circuit, they will use up more energy and the battery will run out faster. Okay? So in that case, right, the battery will be used up faster and then your battery will eventually be used up more quickly, earlier. So there's a disadvantage. Right? Then it will be the opposite for series circuit, right? So if the bulbs in series are dimmer, then the battery will last longer. That's the advantage. But this advantage is that they will be dimmer as compared to those that are in parallel. And if one of the bulb fuses, then the remaining bulbs will not light up. Okay, so that's disadvantages. All right. Okay, one disadvantage one of you mentioned is we cannot control each bulb individually. Yes. So if one of the bulb fuse, the rest cannot light up as well. Okay, that's correct. Okay, moving on. Okay, so we go to the questions. I hope you have tried the questions. I have a lot of Q&A, a lot of questions in the Q&A. Can they ask how the bulb is fused? Ganesh, how the bulb is fused is most likely because there's too much electric current and the filament melts. So the bulb has fused. Okay? Hmm. Okay. Elsa, when using too many batteries, too much electric current flows through, so the bulbs may blow. Okay, the bulbs may blow, and then they cannot work anymore. Why is 2 over 1 2 units? Tiffany, 2 over 1 equals to 2, right? So that is 2. So the units, we just put it as units. Okay? Okay. Now, let's go through the questions. Question 1. What do you think is the answer for this? Answer, okay, I have a few answers already. Some of you say the answer is 3. Okay, the first one is a bit more basic if you have listened just now. Okay, this is just a comparison of a parallel circuit with a series circuit. So the one on the left is parallel. The one on the right is in series. Okay, they have the same number of batteries, same number of bulbs. So what would be observed in the circuits? So if you all say the answer is 3, right? So let's look at 3. Bulbs in X are brighter than the bulbs in Y. Okay, so let's calculate. Let's calculate, right, using our formula. So I have 2 batteries, okay, 2. And in this part, I only have 1 bulb. So 2 over 1, that is 2. This one will also be the same, so that's 2. So they are equally bright. If I look at the series circuit, now in this entire path, this is only one single pathway. Yeah? I have 2 batteries, 2 bulbs. So this is 2 over 2, which is 1 unit. So you can see the light bulb in circuit Y will be dimmer than those in X. Okay, so answer is 3. That's correct. Yes, thanks for all your responses. Let me just sip some water. Okay, let's move on. Question 2. So we have 4 circuits now. So which of the following statements about these circuits is correct? Can you tell me your answer? Tanishka, maybe you can write your question again because there's too many responses in both the chat and Q&A. So you can write it again to catch our attention. Okay, please be patient with us. We are trying our best to answer all your questions, but we will not be able to do so for every single one. Okay, because there's so many of you, right? But there's only 2 of us. Okay, so We try our best. All right. Okay, so many of you have answers as 4. So let's see. 4 means A, B, and C. So let's see whether most of you are correct. All right. So we do our calculations again, right? So for circuit S, 2 batteries, 1 single bulb. So this is 2 units. For T, okay, each path only has 1 single bulb, so 1 over 1. So this is 1. This is also 1. For V, there's only 1, so it's just 1. For U, one battery, 2 bulbs, so that's half. Okay, so you can see the values here. S is 2 units, T is all 1 unit, U is half, V is 1. So from here, you can compare their brightness. So bulb in S is the most brightly lit because the value is 2 units of brightness. Bulbs in U are most dimly lit. So it's half units of brightness. So that is correct as well. T and V equally bright. So all of them are 1. So that is also correct. Okay, let's look at D. Bulb in V is as bright as bulb in S. V compared to S. So that's not correct, right? Okay, V is 1 unit of brightness. S, 2 units of brightness. So D is wrong. Okay, so most of you are correct. Answer is 4. Well done. Okay, let me see some of your questions. Uh, okay, some of you are asking for the recordings. Now, do take note that we'll be sharing the recordings on YouTube. Okay, so do follow us at do follow my stretcher at YouTube so you can see the videos uploaded. Okay. Okay, we'll move on to the next question. Next question is 1. Wow, you're not very fast. All capital. What's your answer? Okay, so let's do our calculations again. We just want to look at bulb Q, bulb Q. So this is Q, this is Q, this is Q, this is Q. Okay, to identify the correct light bulb. Okay, so for number 1, 2 batteries and 1 single bulb Q in the path. So this is 2 over 1, which is 2. For number 2, now do look at this very carefully. In this path, how many light bulbs? So this path is here, no? There are actually 2 light bulbs here. Okay, so which means that I have 1 battery. It is 1, right? 1 battery. But in this path, I have 2 light bulbs. So that's half. Okay, even though it's not put in the same line, but it's still in the same path, right? It's just that it's on the horizontal line instead. Okay, so don't be tricked by that. Number 3, we have 3 batteries and 3 bulbs. So this is 1. And number 4 very similar to number 2. This path, there are 2 bulbs. Okay, so this is 2 over 2, which is 1. Okay, so which one is the brightest? Answer is 1. Okay, thanks for all your responses. Yes, very good. Most of you got it correct. Now, you see, right, this question on brightness is tested in almost every PSLE paper. Okay, so please try to practice on this. Can? You can write your answers in the chat. Okay, there's too many responses in the Q&A, so we get a bit. Repeat the answer for question 2. Answer for question 2 is 4. Okay. Next, question 4. What's the answer for question 4? Okay, now I see a bit, a few answers which are different. from the actual answer. Okay, but most of you are still correct. Now, which change will allow all bulbs to light up with equal brightness? Equal brightness. Okay, so let's say I add one more battery. Now, adding one more battery is not going to make them light up with equal brightness. Okay, because you see, right, I have two paths. This is one path, and this is the second path. So these two paths are parallel to one another. So in the yellow path, okay, one battery, and there are two bulbs. So each of them is half. For the one in blue, one battery, one bulb. So this is just one. Okay, but by adding one more battery, that's not going to change this. That's not going to change the formula. All right. So maybe I can add an identical bulb in series to S. So for example, let's do that. If let's say I add another bulb in series to S, so maybe it could be here. So if it's here, it will change my whole formula, becomes 1 over 2, which is half. And that makes it the same as Q and R. And now all of them will be half. And that's why the answer is 2. Okay? Just now I saw some of you wrote 3 or 4. So let's look at them. Add an identical bulb in parallel to S. Okay? So I'm going to change all this. I'm going to erase this. Let's say I add a bulb that is parallel to S. So add parallel to S means that I add another loop, another pathway, like this. Will all the light bulbs light up with equal brightness? So think about it, right? So for the pathway with S, there is still only just one light bulb. So there is still 1 over 1, which is still 1. And for the new one that is added, it is still also 1 over 1. So they are not all the same. We're talking about all the light bulbs with equal brightness. Okay? So in fact, number 3 and number 4 are the same. You add parallel to S, it's the same as it's parallel to Q and R together. Okay, so that doesn't change the answer. All right. Now again, yes, some of you say you did this in maybe one of your weighted assessment in school. So this is one of the quite a common type of question also. So do practice on this as well. It had been tested in PSLE before, something similar to this. Okay? Okay, let's move on to the drawings. Get more and more complicated. Okay, number 5. So what we have here, she noticed that both bulbs did not light up, even though she had replaced it with several new ones. Okay, that means that she tried with a new bulb, but they still did not work. So what is the issue here? Wow, okay. Connect metal tip of bulb to metal case of bulb B. Okay, and metal tip of B to metal case. Okay, so we have a few errors in the drawing, right? Okay, so you can see that this light bulb not connected correctly, 2 wires to the metal casing. Likewise for B. And what happens to the batteries? Connected wrongly. All right, so we have to put them correctly. Okay, so how do we put them correctly? So most of these things must still be the same. Most of these must still be the same. Let me just zoom out a little bit. I don't have the space. Okay, so I'm going to use freehand and try to draw as neatly as possible. Okay, this is what you can do in PSLE as well. So you just draw. Okay, I have the 2 batteries. I need to put them in the correct order. Okay, so now they are in the correct order. Connect it to the switch. Okay, and this side here, I can choose to connect it to the metal tip. The other one, connect it to the metal casing. Okay, and here I connect it to the metal tip. Okay. Can? So you see, I did not really draw straight lines. I purposely draw a curved one, but is that still correct? Technically still correct. Okay. No, some of you ask whether you can use lines for the batteries. No, you don't. Okay, because what you are given here in the question are incorrectly connected batteries and bulbs. So what the question wants you to show is how you draw and connect the actual batteries and bulbs, not using circuit symbols. Okay, so do not draw like this. Do not. They want you to draw like what they have done. Okay, so do not use circuit symbols here. Yes, you can draw casing to casing. Okay, you can draw casing to casing. So I give an alternative answer. So some of you would ask whether you can draw casing to casing. Yes, you can. So this casing, I draw it to casing. Then the metal tip here goes to the battery. This is fine. No problem. As long as the light bulb is connected correctly. Okay, so this is okay. Can I? Okay, let's move on to the next one. Yeah, let me see if any important questions I need to cover. How to, okay, yeah, I think all these needs. Okay, I move on to question 6. So that was a simpler drawing question to correct the connection. Okay, so next part, question 6. So in this, we have a slightly more complicated setup. Okay, there's an iron cylinder. So iron cylinder, you can see, right, this is going to become an electromagnet. Okay, this will become an electromagnet. Those who are in P3, you should recognize these, right? The wires quite around the iron cylinder, so this becomes an electromagnet. Okay, so what we have here, the iron striker can swing about point P. Okay, so this is like a fixed point. So this iron striker can swing about point P. So how does it swing? Maybe it swings like this. Use another color. It swings like this, for example. Right? Because it's fixed at point P, right? So it only swing around at the point P. Okay, so what happens? There's now a spring here, the spring fixed to the iron striker and the wall. Okay, so describe what will happen when the switch is closed. Okay, so what will happen when the switch is closed? Now, in this case, you have to describe like what you would see. Okay, not just what you will see. Okay, so talk about the science concept here. When we close the switch, what's the first thing that will happen? Go through the whole thought process. All right. So, one of you raise your hand. Elizabeth, you want to answer the question? Since you raise your hand. Or you see.
When the switch is closed, the circuit will be completed and the iron striker will work. And
Okay. Thank you for your response. That's not good enough. Now we need to talk about the electric current, talk about the electricity that's flowing through the circuit. Okay. So thanks for your response. So when the switch is closed, first thing is, yes, the circuit is closed. So what happens? There is an electric current flowing through. And when the electric current flows through, then the electromagnet is the one that is working. That's how you mentioned the iron striker is working. But first, the electromagnet must work first, which will then attract the iron striker. So the iron striker will move towards it, and that's it. Okay? So this is my response. Let me just put it here. Hold on, ah. Okay, now can see. I'm going to zoom in. Okay, so electric current flows through the circuit. Okay, we must mention the iron cylinder becoming an electromagnet, which will then attract the striker, the iron striker. Okay, not the football striker, the iron striker. All right, so the iron striker will swing towards it. So that's the first thing that will happen. Can? Okay, just spend a few seconds to copy this down. And do take note again, the recording will be uploaded for in the YouTube. So if you really miss out on the answer, you can always refer back there. You will always be there. Okay? So most importantly is to understand, because you can copy all this down later. So I'm going to move on to part B. When the switch is opened, a ding sound can be heard. Explain why. Why would there be a ding sound? So when we open the switch, what happens? Okay? I think some of you raising your hand already. Glory, do you know the answer, Glory? But Glory, are P3?
Yeah.
Okay.
So when the switch is open, a ding sound can be heard. It is because whenever the spring is open, then the iron striker will be switching and then will be banging the bell.
Okay. I did not hear the correct keywords, so maybe I let another person try. Keith?
How do I say it? I don't know.
Answer is when the iron string striker is attracted to the electromagnet, the spring connected to the iron striker will extend, thus it will exert the elastic spring force on the iron striker, and then when the switch is open, an open circuit is formed, and electric current will not be able to flow through the circuit, thus the electromagnet is demagnetized and does not no longer attracts the iron striker. Thus, the iron striker is pulled back by the elastic spring force and hits the bell, creating the ding sound.
Well done, Keith. Well done. Very good. Thanks for your response. So, okay, you have given a very detailed
Help of
response.
me.
Yes, well done. Okay, so this is my response here. Very similar to what Keith has mentioned.
So smart.
Okay, so you talk about, because now we talk about the switch is open, right? So switch is open, that means that now there's no electric current flowing through. The iron cylinder will lose its magnetism. It is no longer an electromagnet at this point of time. And with that, it cannot attract the iron striker. Hold on, why is the word cut off? Okay. How the word is cut off? Okay, so what happened? Okay, you all see it like this. Okay, so no longer attracts the iron striker. So remember just now we talked about the spring, right? There's a spring. So the spring will pull it back. And just now Keith mentioned that there's elastic spring force. Very good. Okay, but not really needed for this question. But okay, if you mention that, it's not wrong. So you will get pulled by the spring and the striker will hit the bell. Okay, very good answer. Okay, right. Okay, moving on. State a change that can be done to the setup to produce a softer ding sound. Okay, so it produces a ding sound because the striker hit the bell. So what can be done to make it a softer ding sound? Now I have a few answers for this. Okay, and I think this one I will not ask anyone to answer because I think we don't have the time. So for this, these are the few answers that you can write. I don't know why the thing keeps flicking. Okay. So you can use a spring that is less stiff. For those in P6, you should have learned about the stiffness of the spring. So if the spring is less stiff, you will pull the iron striker with a smaller force, and therefore it will hit with a softer sound. Okay? Other ways to do it is to make the electromagnet weaker. And that is by removing one of the battery or two of the batteries, or we just reduce the number of coils. So that will make the electromagnet weaker. Okay, so you attract the iron striker with a smaller force, and therefore when it strikes the bell, you will not have a big force. Okay, it will be a smaller force. Okay. Yeah, those who talk about the coil, yes, that's in my answer also. Okay, okay, I move on to the next question. Back to drawing. Weaker battery, weaker battery. Weaker battery also can lah, but it's easier to just say remove one battery. Okay. Now let's talk about 7. So 7 again is about connection of the bulbs and battery. Okay, now we have something different. Now this is a fixed metal plate. These are fixed metal plates, means that they cannot be moved. They are made of metal, and that is where you are supposed to put the batteries. Okay, it's just like if you go and open up your remote control at the back where the batteries are, they all have these fixed metal plates. If you realize, if you have not explored that, you can go and take a look later. Okay, you have all these fixed metal plate where all the batteries are placed. All right. So how do we connect it? So these are the observations we must observe. Okay, so let's go through each of them. So bulb X lights up when bulb Y lights up. So it could be that they are in series. Okay, it could be that they are in series. So in series, perhaps we just put KIV first, key in view first. All 3 bulbs light up when the switch is closed. Okay, that is not enough to tell us anything. The third one, only bulb Z lights up when the switch is open. When the switch is open, bulb Z is still connected. That means that the switch will only controls X and Y. Okay? The switch will only control X and Y. Z is not connected to the switch. Okay, so that is one thing to keep to remember. So let's try to draw them. Right? If when Z lights up when the switch is open, right? That means that Z is likely to be parallel to X and Y and the switch. Okay, so that's another thing that you can take note. Parallel to X, Y, and switch. Because the switch is connected to X and Y, right? Okay, so if it's not connected to the switch, then it must be parallel to X and Y. So let's start to draw this circuit. Right, we have the battery here. So how should we draw the battery? So the battery, right, we must draw it in the opposite direction. This one very important. I have students always draw this wrongly. Okay, now this battery on the right is upright. So now your battery on the left must be downwards. And don't forget, you must have the head of the battery. Okay, remember I told you some students will draw rectangle, which should not be the case. Okay, so in this case, we can connect the wires to Z first. So you can see, right, this is how you can draw a wire, a piece of wire connected to the casing of Z. So maybe I have another wire connected to the tip of Z. So now it's a loop on its own. It's a closed circuit on its own. Okay, then I can have the second loop. Now they are parallel. So this part here, metal casing, I can have here. Let me just draw my switch here. This is metal casing. Okay, then from the metal tip to here. Okay, so you double check all your connections first. Okay, my battery is drawn correctly. My light bulbs, all three of them, metal casing, metal tip. Okay, now let's go through back this part on how they light up. So X light up when Y lights up. So they are in series to each other. Okay, they will for sure light up together. All three lights up when the switch is closed. When I close the switch, all three are in the closed circuit. But when the switch is open, only Z lights up. So that is correct. Okay, when this switch is open, X and Y are in the open circuit. There's a gap here where the switch is. Okay, Z is still in a closed circuit. So this is the answer. If you put your switch between X and Z, yes. So if let's say, okay, I just remove this switch here, I'm going to put it somewhere else. So one of you asked if you put your switch here on the right side, yes, that is also possible. Okay, but maybe I have to draw it like this. That's still okay, no problem. Can? As long as it's on the red color loop. Can? Can Okay, let's look at the next part. Comment on the final brightness of the bulbs. Final means that after whatever happens, what is the final brightness? When we have another identical bulb that is connected in series to bulb Z and the switch is closed. Okay, so now I'm going to add another light bulb. So this one in different color. What color should I use? Okay, green maybe. So I use green in series to Z. So let's say I connect another light bulb here. I connect it correctly lah. Okay, let's say I connect it correctly. Okay, I connect this correctly. Now, how are they arranged? Can you see that in each pathway, I have two light bulbs. I have two batteries, two light bulb. Two batteries, two light bulb. So essentially 2 over 2, which is 1. And therefore, all the bulbs will be equally bright. Okay? All of them will be equally bright. So that is the answer here. Okay? Okay, do take note, my green color one is the additional one. I did not shift the wire because that is the original answer to part A. Okay, but assuming that I have connected it correctly. Yes, all the bulbs have the same brightness. Okay. Okay, we have must the switch be closed when drawing or open? You can draw the switch closed or open, is okay. Okay, now we have a lot of questions in the Q&A. Like I said just now, we won't be able to answer to every single one of you. Okay, but if let's say later when we finish up the last question and you still have a burning question to ask, okay, you can stay behind and ask the question. All right, so we'll move on to the last question, which is very long. Okay, we have not say very, very long, but okay, long enough. All right, so this question can be a little bit complicated, okay? But these are all, you see all these questions, why they are here. We are all testing you on a question that has been recently tested in PSLE. These are trending questions. Like I said, the electricity question has been heavily tested in the last 3 years. And these are questions which are modified based on the PSLE questions. Okay, so the concepts here, you must fully understand because it might come up again. Okay, what you see in the PSLE 3 years paper, three-year series in 2025, in 2024, some of the question actually came out maybe in like 2021. Not exactly the same, but the idea is the same. Okay, the concept is the same. Okay, so make sure you know this. Right. So they say that the moves between A and B repeatedly. So it moves up and down, moves up and down. Okay? So explain why the magnet moves between A and B repeatedly when the switch is closed. So again, we must go through that whole thought process. When we close the switch, then electric current flows through, then it causes the whatever thing to become an electromagnet. Okay, so go through this whole process step by step. All right. So first thing, I close this switch. When I close this switch, assuming that the magnet is still at A, yeah? So now this is a closed circuit. Let me just draw it out. Okay. When the magnet is still at A, this is a closed circuit, right? So the magnet closes the gap here. So this is closed circuit. All right. So when this happens, this fixed iron rod, okay, becomes an electromagnet. Right? So what happens when it's an electromagnet? It can either attract the magnet or repel the magnet. Okay, but the thing is, they say that the magnet moves between A and B. Then it repels. Okay, repel. It had been repelled by the electromagnet. Because now both are magnet, right? So that when the light poles are facing each other, they repel. So now this magnet move up to position B. Okay? So we have already answered the first part, why it moves from A to B. But how do we talk about why it moves back down? Okay, because it said move between A and B repeatedly, right? So we have talked about it move up. How do we talk about it move down? Okay, so now when it moves up, this becomes a gap. Right, because initially it's a closed circuit because the magnet is in contact with the metal contacts. But when it moves up, that becomes a gap. And this electromagnet stops working because it's now an open circuit. And therefore, it's no longer repelled, it will fall back down. Okay, so when it falls back down, it's going to repeat this whole process again when it touches the metal contact. Okay, so you must understand this whole process. All right. Okay, so the answer can be quite long. All right, so in PSLE, you can see this electricity question, such a question, even the PSA paper, they give you 5 lines around there. Okay, if that is what is required to write so long. Okay, so this is the answer here. Just make it more readable. Okay, when the switch is closed, current flows through the circuit, then the iron rod becomes electromagnet, repels the magnet from A to B. That's the first part, where it moves up. Okay, then the second part is when, after it moves up, now there's a gap. Then the circuit becomes open. Okay, so the electromagnet stops working, magnet will fall back down, close the circuit again, and repeats the whole process. Okay, so that's why the magnet moves up and down. Okay, so you must be able to produce this answer. Even though you see this is difficult question, right? Because it's only 2 marks to write so long. But that is what's tested for PSLE. Okay, unfortunately. Okay. Yes, Jude, your answer is, although it's just giving a very brief answer, but I think you got the idea, Jude. Okay. Now, next part, not the last one. Next one. Okay. When the magnet is at B, state how the brightness of bulb P changes. Okay. So the magnet moves up from A to B, right? So let's say now it is momentarily stationary at B. It stops at B for a while. How would the brightness of bulb P change? Okay, so initially, initially when it is at A, how many bulbs are there in series? Okay, P, Q, R. 3. We have 2 batteries, so 2 over 3. Okay, this is initially, okay, at the start. When when the magnet is at A. Now, when it's at B, when it's at B, what happens? When it's at B, then now the circuit is only this small. This is the smaller circuit that is present when the magnet goes to B. And how many bulbs are working? 2. Okay, so 2 batteries, 2 bulbs. That is 1. So what's the change? From 2/3 to become 1. So it must have increased, right? From 2/3 becomes 1. So this is an increase. So the bulb becomes brighter. Okay? Because now R is not part of the circuit when it's at B. Alright? So you have to explain that. Okay, first thing you tell me how the brightness changed. So it becomes brighter. Okay, it becomes brighter. The explanation you have to. Okay, now remember just like I told you at the start, right? We give you the formula, but the formula is just a strategy to understand the question, to know the brightness. But when you come to actual explanation, your explanation must be in terms of electric currents. Okay? It must be in terms of current, how much current is flowing through, and therefore the brightness. Okay? So you talk about when it is at B, there's more current flowing through because there are only 2 bulbs. As compared to when there are 3 bulbs when the magnet is at A. So you can compare when it's at A at B, there are 3 bulbs, there are 2 bulbs. Okay? And that leads to more current flowing through when there are only 2 bulbs. Okay, so it has to be in terms of electric current. Okay, do not mention that formula in your answer. Okay, the formula is just a trick. It's just a tip. Okay? Hmm. Hmm. Chloe, what other hot topics will be tested this PSLE? Everything is tested for PSLE. What are you talking about? It's about how heavily they want to test for each topic. Okay, so last 3 years electricity has been quite heavy. I will not be able to guarantee you that this year is going to be as heavy. Maybe they only test 1 question, 2 questions. I really cannot tell. But based on the trend, it might still have quite a big weightage here. But like I said, cannot guarantee. So please study for all the topics. Okay, one
Okay.
last part. One last part. Sorry, we have someone who spoke.
It is just because I don't have the paper, that's why.
You don't have the paper. Oh,
Yes.
okay. Uh, just now we give the link, right? Okay. You can look at the link again. The paper should be inside. Okay, last question. Last question before we end off. Okay, so after operating for a few hours, now the magnet moves slower than before. Okay, so this magnet, just to recall, right? So the magnet moves up and down from A to B, B to A, keeps moving, but it moves slower. Right? at the later part of the experiment. Okay? State another change to the movement of the magnet. Explain your answer. I just want to see some of your responses. It moves lower. Okay, it moves lower. Maybe your answer can be a bit more specific, clearer. Make your answer clearer. Okay. One of you say, Nikum says that you will not move as high as before. Now that is better. Okay. So do take note, you still have to mention that it moves up. Thus that it will not be as high as before. Okay. So be very clear on how you describe that. All right. Now, how do you explain that? Now, the easier way to explain this question is using electric currents again. Okay? Okay, so my first answer here is in terms of the height. Okay, so it moves up to a lower height than before. Okay? Or some of you mentioned it will not move as high as before, also can. Same meaning. Now, so the easier way to answer this question is in terms of electric current. So, you know, right, when you use a battery for a long period of time, it will get used up. So less current flows through the circuit now. Okay, you see all these answers are in terms of current. Okay, electric current or electricity. You can use either one, but the more accurate term is current. Okay, so less current flows through the circuit, then we have a weaker electromagnet. Right, because you know the strength of the electromagnet really depends on the electric current, right? The stronger battery you use, or the more battery you use, the electromagnet becomes stronger. So now it's the reverse. Now the electromagnet is weaker because now we have less electric current. Okay, so the repulsion is weaker now. Okay? Yes, repulsion is weaker, so move less higher. So the more complete explanation must include the current. Okay, if you just mention about the repulsion being weaker because of weaker electromagnet, it may not be complete. Okay. Okay, I see one answer here. Magnet rise to a lower height. Less chemical potential energy of the magnet, not of the magnet. I think you meant of the battery, converted to less electrical energy of the circuit. Okay, so iron rod becomes weaker electromagnet, and cause yeah, I think Leonard, that is okay, except that the magnet is wrong. Okay, chemical potential energy of the battery. Okay, so you can actually explain using energy in this question. So I give you another alternative answer here for those who use energy. So I think this will be in line with what you have written, Leonard. Gravitational pull. Now, you don't need to mention about gravitational pull. Just talk about the repulsion being weaker. Hmm. Okay. Can. Okay. So now we have completed this whole set. So remember, all these questions are really very important questions and some of the key type of training question that PSLU they will test. All right. So please go through this whole worksheet again, especially if you are not so strong in this topic. Okay, especially those drawing questions. If you have trouble trying to draw correctly, draw the correct connection, please try it again and again. Okay, you can print the worksheet 100 times, go and practice 100 times. Okay, in order to get your AL that you want. All right. So so we have actually come to the end of this session going through this topic on electricity. Now, in the case any one of you still have burning questions, you can stay behind and leave your question in the chat so that we can answer directly. Otherwise, we have actually come to the end. So thanks everyone for joining today's session. All right. I hope the session has been helpful. Okay, and all these questions are really useful for your practice for the PSLE. All right. So thanks for joining us this evening. Do look out for more sessions. Okay, we also have our last lab bootcamp. Okay, we have our bootcamp coming up in September. I think holiday. Okay, so do look up for it. Do look up for it in the MyStretcher website as well.
Okay.
Thank you.